Please welcome back Kyle Ellicott.
Thank you, Nashville. As I stated just moments ago, we've got two rockstar panels to close us out here at Day 2 Bitcoin Builders Nashville. As we transition from our first half of today, talking about everything from fundraising to clarity to BNS and much more, including setting the table around Bitcoin layers, we're going to continue that discussion and look at the new frontiers in Bitcoin scaling. Ladies and gentlemen, a big round of applause for my panelists and Yanju of Nubit, Matt of Arch Network, and Esad of Citrea. Big round of applause. Welcome, welcome, gentlemen. We are here in Nashville at Bitcoin Builders Conference. We are in the heart of Bitcoin country. The last day and a half, we have had a ton of discussions here at Bitcoin Builders all around Bitcoin layers. And one area we have yet to touch on, which is why we're all sitting here today, is scaling and scalability in general. Each of you represent a different protocol or a different network that's focusing on something different when it comes to scalability. One term that comes up a lot around scale right now is the term UTXO. And there is some discussion of pros and cons around UTXO in general, but also UTXO-based layers. Love to kind of kick us off and dive right in. What are the pros and cons of UTXO-based Bitcoin layers? Matt, I'd like to start with you.
Yeah, sure. So when we look at the context of programmability in the history of crypto, right? It was very much prioritized by the core contributors of Bitcoin to prioritize uptime, security over expressivity and programmability. So that left this void for more performance and programmable chains like Ethereum and Solana to come into the mix and offer this utility. So what they introduced into that is this concept of accounts, right? And that is very different from how Bitcoin and other UTXO-based chains operate. So there's this inherent disconnect between EVM compatibility and UTXO type chains. So when it comes to these scaling solutions from an L2 perspective, which we've seen all this play out on Ethereum right now, where you have all this modularity and L2s for scalability, it makes sense because you have the EVM that's kind of keeping everything aligned and keeping everything interoperable. But from the EVM and to actually connect to the UTXO model on Bitcoin, it actually is quite difficult. So we have quite a bit of infrastructure and tooling that's necessary to be built before we could actually scale Bitcoin in the kind of way that Ethereum is doing it. So,
Yanju, anything to add?
Yeah, I think I agree with Max. So I think one of the cons of UTXO would be the programmability. So it would make it a bit difficult if you want to do anything that what you used to do on a local computer. It's like you cannot. So I think its data structure and also its data structure is also limited. So I think that's also one of the main concerns that we here in Nubit that we're trying to resolve or trying to mitigate, because we have we designed some DA layer and also an execution layer, which will allow better programmability that could be possible to overcome the cons of a UTXO model. So that's the way that we are trying to head to. Yeah.
Esad, anything to add?
So, as all of things in life, there is no good and bad here again. I think it depends on what you want to accomplish. Like, what is your layer aiming for? Is it trying to be like some high throughput payments layer, or are you aiming for some kind of being the base layer for DeFi? You want like complex programmability, or you want like simple payments? So if your layer wants like to be the payment layer, you want to have high throughput, you want to have lots of nodes, maybe even light clients. Maybe UTXO-based layers might be for you. If you want to have like programmability, you want to have like smart contracts, you want to build applications on your layer, you'll it's going to be much easier to work with an account-based blockchain like Ethereum, I mean like the VM, the state transition function, like the EVM or the SVM from Solana. So decision depends on what you're trying to aim for.
So let's talk a little bit about some recent news, Esad, for you and relevant in terms of Citrea is we had announcement about a few days ago from Starkware that they had verified the first ZK proof on Bitcoin testnet. And then just recently here in Nashville, the news came out, Bitcoin OS had verified the first ZK proof on Bitcoin mainnet. What are your general thoughts on this recent announcement news from the side of the future of proofs? Is this something that is just a great moment, a great milestone, a new era when it comes to Bitcoin and scalability?
So any kind of improvement is great for the Bitcoin ecosystem. So first, grateful for both teams to put up some good work. I mean, I haven't really went into detail with Bitcoin OS's verification, but I know the Starknet team used the recently activated OPCat on Signet, which would allow us to both verify ZK proofs and simulate covenants on Bitcoin without like requiring any additional soft forks or hard forks, right? So that's great because like even if we had something like OP ZK verify, we would still need some form of mechanisms to support covenants because even if there is like a script we deposit and withdraw from, we'll need to limit how those UTXOs will be used in future transactions when people are withdrawing, right? So you still need covenants. OPCat is enabling both, and it's great. For somebody that is building a rollup based on a BitVM bridge, it's really exciting to see because with BitVM, what we get is, yes, we can verify a ZK proof on Bitcoin, but it's an optimistical verification, right? If there is a ZK proof that was posted to Bitcoin, which verifiers saw and said, hey, okay, there's a ZK proof, but we cannot verify it. Let's challenge the operator, let's challenge the sequencer, whatever, right? Then you'll get somehow a game that is played between different actors of the rollup, try to convince the BitVM contract about what is right and what is not. So having OPCat and directly verifying ZK makes this whole operation much more simpler and much more efficient. However, there is a catch. On the BitVM scenario, what you get is 99% of the time when there is no dispute, when everybody is acting honest, there is no on-chain footprint, right? No costs, no transaction spendings, and that's great. On the ZK, only fully verified, like OP-ZK verifier or OP-CAT scenario, what you get is you have to do everything on-chain, right? You have to settle on-chain, let's say every day, let's say every hour, maybe every block if you want to pay that. So there's a bigger footprint of having directly verifying the ZK proof on Bitcoin as well.
So that brings up an interesting conversation as well, is the idea of why rollups may or may not work on Bitcoin and Bitcoin L1. As I said, this is the beginning, right? We've only seen a few tests, a few trials of this. Matt and Yanju, I want to start with you on this. Is maybe why could rollups or maybe not work on Bitcoin L1, Matt?
Well, I think certainly rollups are going to be a needed concept for scalability because we're certainly on Bitcoin L1 confined to certain limitations, right? You have 10-minute block finality, which is certainly a limitation, and then within the data component, it's only 4 megabytes per block. So there's only a very finite amount of data that you could actually put on that block. And as DeFi starts to unlock on Bitcoin, which it certainly will do so as tooling and infrastructure becomes more useful, you're going to have a lot more demand for that block space. And so a roll-up type of infrastructure certainly makes sense, but what really matters in that construct or that design choice is the various trust assumptions and threshold signature schemes and ways that you actually can reach consensus in a trust-minimized way. That's ultimately what matters in the context of a roll-up, so that when you ultimately do bring that data back on-chain, you know that from a user perspective that it's provably secure. And in the context of the Bitcoin OS ZK verification on chain, I think it's certainly like a milestone moment for Bitcoin. We're experimenting with various cryptographic functions and doing the ZK proofs on chain, which is certainly fantastic. I think the opcat is a little bit more useful because I think it was like 51 transactions were needed to actually do that fraud proof via the Bitcoin OS implementation. It cost like $165 just to do that one execution. So I think that's probably a little bit more novel and not useful as opposed to the opcat design, which is a little bit more useful.
Yanju.
Yeah, I think Matt made a great summary about the pros and cons. I'll just add a bit more from the Nubit team's perspective, because we have been thinking about this problem ever since we founded Nubit. And then I think, yeah, for sure, Bitcoin layer 1, it's the data stored there could be slow, and the TPS could be low, and then the throughput could be very small. And then another point is that there on Bitcoin layer 1, then you may not be able to kind of like read data from the other DA layers. So there's kind of this restriction here. And then, for example, in the future, we would expect more different kinds of applications that require more data storage and data access there. And this would naturally restrict the capability of accessing those data. So that's the reason why we have developed our solution, which has two components. One is the DA layer, and the other will be an execution layer that actually expands the capability and programmability so that people could be able to program as what they used to do on their local computer there. And this also opens up some new opportunities for the layer 2 different applications. I would like to follow some more points about the ZK proof question that you just asked.
Please.
Because currently, I myself, I'm a big fan of ZK proof. And I also work in ZK and different aspects of ZK, including developing ZK proofs and also checking bugs in ZK. I also personally developed a ZK bug finder there. And then we also have experience in ZK EVM, so we know what kind of these kind of pros and cons of ZK can bring to Bitcoin. So in terms of bringing privacy to the data and also to the computation to Bitcoin layer 2, I think ZK would play a very important role. But as people would also know that it's a bit difficult. The learning curve of ZK would be pretty steep. You need to kind of learn a lot of things there. So I think this is also one potential challenge that we need to resolve. But I think from the other ecosystem, for example, EVM, they also have these ZK rollups at the second layer, and also they're defining something like a ZK EVM. They use ZK proof to prove the entire EVM system. I think there's some kind of very good examples that I think from the Bitcoin community can also borrow from. And also the next step would be they want to build a more generalized ZK VM system, which if we use that, the user can actually write the programs as what they are writing on the local computer, and that ZK event infrastructure would automatically generate ZK proofs for you that represents the program logic that you have. The user doesn't need to worry about anything about cryptography or anything. So I think that's some great opportunities that we can actually use right away in order to push this forward. So yeah, actually, I think Nubit's DA layer is actually using ZK proof to actually provide proof for the data that we upload to the DA chain. So I'm pretty happy about this and optimistic about the different opportunities there. Yeah.
Yanju, I love the optimism. I want to challenge something, though, that you mentioned earlier around the data availability layer of DA. Yeah. There's a lot of discussion around data availability for the Bitcoin ecosystem and Bitcoin layers. There's some talk that it's good or it's not good on the Bitcoin L1, and there are plenty of constraints in today's environment. Walk us through kind of why Bitcoin L1 may or may not be a good DA, a data availability layer, and what some of those constraints are today.
It's interesting. I just talked with some of my colleagues a few days ago about this question. So I think Matt and Esad has made some kind of summary about the cons of storing data directly on Bitcoin L1. So I'll add several more points here. So because first of all, it's maybe expensive, and also the Bitcoin's L1's native language doesn't allow you to access data freely from other DA chains. So it means that if you build DA on Bitcoin L1, it means that you have to suffer from this high cost, high gas fee, and also the limited block size, which is not scalable. So back to the topic today. So that's the reason why I think DAL1 may not be that suitable for directly storing those data. But we do think that it may be suitable for storing proofs or some kind of consolidated information or proof or data routes there, which provide just a receipt or a proof of your data generated, so that you can use that, maybe the receipt, to actually access the data from somewhere else that can provide you with cheaper access of the data and faster access of the data. So I think that's the reason why we think like DA may find a suitable place on L2s, maybe not L1s, but we also welcome new solutions there. And then, yeah, if we can solve the aforementioned issues on L1, that will also be great.
Matt, thank you, Yanju. Matt, to you, a question you and I discussed a little bit ago yesterday around multi-sigs. So how will multi-sig and some of the resulting consensus designs impact trust assumptions and security going forward?
Yeah, this is an incredibly important point, because I think that within a lot of this design space, you have very different builds and different constructs that have various levels of risk or trust factors, right, or attack vectors. So from a front-end user perspective, it's very difficult to understand what types of trust assumptions that you're making on this network. And in the time of the state of the market where we're at now, there's a lot of venture-backed startups claiming these buzzwords on their websites, putting retail into a position where they don't really understand much about these nuances. And in the case of these multi-sigs, they're a very critical component within the context of programmability on Bitcoin, because they ultimately have the conditional expressivity or the conditional execution that's needed in Turing-complete smart contracts. The only thing is that there's multiple different concepts or theories about how to make this more secure and reach consensus. So, you have scripted multi-sigs, scriptless multi-sigs. You had Musig that eventually came around, and now you have Frost. So there's all these different implementations of thresholded signature schemes and these multi-sigs that ultimately can sign with their keys to actually allow for this, state transitions and asset transfers, which are the basic, fundamental pieces of a Turing-complete smart contract. So I think that multi-sigs have gotten a bad rap in the past because they're, kind of synonymous to just these keys that anybody could be holding, and that can be somewhat centralized, right? So multi-sig equals centralized in most people's minds. But in reality, there's a variety of different design choices and constructs that can be utilized to make it much more trust minimized, or possibly even trustless, depending on what type of design choices that are made. So in the context of Arch, where we're doing our ZK verification, we're actually using an implementation called Frost plus Roast, which is fairly robust and performant, extremely secure. And we're using validity proofs as well, which is also reaching majority consensus as opposed to assuming that it's correct and then waiting for a challenge period, which is what the ZK verification that just occurred, and also the implementation of BitVM. So there's various degrees, and I think Citrea, you guys do some additional verification on top of the optimistic setup on BitVM or some fork of that. So there's all these different degrees of decentralization and attack vectors when it comes to these multi-sigs. So I think that that's a very important thing to understand, especially if you're a user wanting to, or a developer for that matter, choosing which chain that you ultimately want to build your dApp on.
Esad, anything to add?
Yeah. So with the current state of Bitcoin script and Bitcoin's capabilities, any kind of, as of now, any kind of bridge we're going to implement will depend on some sort of multi-sig. And traditionally, we've seen threshold multi-sigs, N of M trust assumptions, right? With these, the problems are somehow through some different mechanisms. If this protocol is permissionless, you can get access to the majority of the keys, and you can be, you can steal user funds, you can send them to whatever you want, and stuff like that. So one of the improvements we get with BitVM and Taproot is that now we can create n-of-n multisigs in a secure way, enabling us to have one-of-n trust assumptions, meaning that as long as a single party that holds the keys to this multisig is honest, you can have an honestly operating bridge. So I think that's a great improvement over the current bridge implementations. And if we get, again, like as the last time I spoke, if we get something like OPCAT or OPZK verify, we'll even get rid of like multisigs probably and just have Bitcoin script secured bridge. So I'm really optimistic for that, but we'll see if we can pass OPCAT or OPZK verify or something that has similar capabilities in the near future.
So you mentioned we'll see about OPCAT. What do you think some of that hesitation is? Why do you think we're not seeing that today? Why do you think that that's a little bit of a hesitation of, yes, maybe if then this, it'll come?
So I can't really come up with like specific concerns about OPCAT, but what we know is around 2011, it got deactivated because it could create like endless size items on the stack while you're emulating the Bitcoin script. And it's created problems with like, especially nodes with smaller memory.
Yeah.
So I understand the concerns around OPCAT because you have to have good limitations around its ability so that you don't really require a very big node for everybody to run a Bitcoin full node. Apart from that, the people who are like going for OPCAT, we want OPCAT for some specific use cases. Like we want to verify ZK proofs so we can have bridge to rollups. This might concern some people because rollups will come with like different usage of the base layer, the Bitcoin, apart from just payments. So I think events like these, talking about OPCAT, what benefits it has and what risks it has, which I think there is no risks associated with it. I think it would be beneficial to pass OPCAT.
Matt, over the last 7 months, we've seen a surge or a big evolution of the term Bitcoin layers, going from a few layers to many, and also a very evolved technical stack. That said, how do Bitcoin layers evolve from here? Looking ahead from a year, 2 years, maybe even 5 years down the road, what's your view, whether it's how Arch or others will play a role in Bitcoin layers going forward?
Yeah, I think we have a lot of experience to draw from in the previous cycles, especially getting to watch DeFi unfold on Ethereum and how they are addressing this modularity and scalability concerns, right? So we're going to certainly see like a much more accelerated timeline on seeing how we can make these type of layers evolve using data availability, using interoperability protocols, et cetera, trying to create less fragmentation among these layers. But I certainly do think you're going to see a lot of consolidation over the next 2 years. Like, I certainly don't think we're going to see 80 L2s continue to, achieve scale, mostly because of that fragmented liquidity that you're starting to see on Ethereum right now between like Base, Arbitrum, Optimism, Blast. It's incredibly fragmented liquidity, which is not, that good for a growing ecosystem that you're trying to make much more inclusive for everybody. So I think that these layers are going to continue to scale. Stacks is leading the way, doing it the right way, by the way, getting the right signers, making sure there's enough economic security in the network, not building this like architecture that doesn't necessarily have meets that don't end, which I think a lot of this borrowed economic security, like the Eigenlayer and Babylon thing, is a whole nother conversation that we could probably do a whole panel discussion around. But I think that we have to like take the long approach and think about what is Bitcoin lacking, what does it need, and how do we ultimately create an infrastructure and an ecosystem that can support DeFi and support all these different utility for the greatest, decentralized asset class on earth with over $1 trillion in liquidity. That's an enormous amount of liquidity that can be utilized in the way that it was initially intended to. So I think that it's certainly coming. Layer 2s are going to be here to stay for sure. Here at Arch, we're much more focused on programmability on the layer 1. But as I said before, we're confined to the limitations of Bitcoin. And that's an intentional choice for us. And we'll worry about scalability second after unlocking DeFi on layer 1 first. So, lots of really interesting design choices and teams working on this problem and attacking it. But it's definitely here to stay. And I think that it's very bullish for Bitcoin as a whole.
Yanju, to Matt's comment about what Bitcoin may be missing in terms of a technical stack, what's your thoughts and opinions on what's missing today that hopefully we'll see developed to see that true Bitcoin utility come to light?
I see. I think, that's a good question and also a big question. So I think, of course, it's missing something, but I think to tell what is missing, I think it's mainly or in most of the cases driven by the application or what people really need there. So for example, this year, people are fond of GameFi or this kind of data-intensive applications there. So this actually require raise very high standards and requirement for data availability. But I think from the past 2 or 3 years, I think people are more concerned about how to improve the scalability or improve the speed of the data block finalization of those chains and of those chains. And at that moment, people will the corresponding technical stack would be building layer 2 and building roll-up layers that will make the data finalization faster. So I think coming back to the question, I think it's difficult to predict what would be the next missing part. But I think I can see an interesting trend here because, for example, previously in the past 2 or 3 years, people are building Bitcoin layers or other blockchain layers in a vertical way. They stack from layer 1 to layer 2 and maybe some layer 3s there. But I think from the most recent year, I can see people are trying to decompose all the functionalities from a large chain into other different kinds of components that lives elsewhere, which provide a faster speed and then more efficient computational powers. So that when you want to call that different kind, you require the kind of computational power, you can just refer to all those other outsourcing components. There you can get cheaper gas fees, you can have better performance there. So I think it's kind of modularity. I think it fits the notion of modularity here. So I think in the future, this may be one of the trends and also brings up more opportunities for developers and also users there.
Esad, anything to add?
Not really.
All right, that's exciting for the future of Bitcoin utility. That said, Esad, coming right back to you, what is your thinking and predictions for new use cases on Bitcoin when we look a year from now? I mean, a year ago, some of the conversations we're having here at Bitcoin Builders, including this one right now, may not have been happening, or also were just a pipe dream of what could be. So now we look ahead 365 days from now. What are some of those use cases?
The use case I'm most excited about is finally having a trustless or at least trust minimize access to Bitcoin, enabling some form of stablecoin. A stablecoin backed by Bitcoin is one of the, I guess, best use cases for payments in the crypto space. Other than that, if we, in the next year, if we have solved this trustless or trust minimized bridging problem, then that means there will be billions of dollars worth of Bitcoin that is now being used in decentralized finance. And I think that's a great, that's something great to have in the blockchain world.
Yanju, back to you.
Oh, that's an interesting question. I was talking to some of my friends from the community yesterday. So we both think that it would be great if we can play FPS or RTS using Bitcoin as a backend. That would be great. Yeah, and I'm optimistic, so I believe this to be true in 1 year.
I love the optimism. Matt, close us out.
I think you're going to see everything that's been tried on Ethereum is going to be tried eventually on Bitcoin. That's my take on things. Certainly, once the infrastructure and tooling is there, which is starting to get to that level, you're going to see the pillars of DeFi that we call them, like DEXs, borrow-lend, stablecoins. That's ultimately what you're going to see first, because I think that's a huge demand, right? You're starting to see meme coins on runes and BRC20s that are finding demand and liquidity. Ordinals have been around for about a full year now that, I've certainly started to find product market fit within the Bitcoin community, finding these digital artifacts that living forever on the Bitcoin blockchain. So I think that eventually you'll start to see all these prediction markets and degen protocols like an Ohm DAO type of thing. Like let's bring back the Ponzi type of stuff and play some musical chairs and stop this dormant liquidity. That's the biggest issue, right? Fragmented liquidity is bad, but what's worse than that is dormant liquidity. And I think everybody, including institutionals right now, which you could probably confirm, Kyle, is like these guys are desperately looking for yield on their Bitcoin right now. So being able to fill that void, I think, is a huge opportunity. And a cool data point that I think that I always go back to is Ethereum ICO'd at $20 or whatever, right?
Yep.
Peak in DeFi summer was 4,000. That's pretty remarkable, come up off of programmability and smart contracts and DeFi. So for everyone that kind of snickers or rolls their eyes when Cathie Wood says $250,000 Bitcoin, just wait for DeFi summer to come 2.0 on Bitcoin.
I love the optimism across the panel. I'm excited to have the same panel and discussion 1 year from now, 364 days, to see where we were right, where we were wrong, and what's to come that year ahead of us as well. Esad of Citrea, Matt of Arch Network, Yanju of Nubit, thank you very much for sharing your thoughts and insights today, and big round of applause, everybody.